Okay, we have the quiz here. Um, let's just quickly solve these equations. 2x minus 8 equals 12. You add the equation 8 equals 8. Put the plus on the 8s just so you remind yourself that you're adding them. Then you get 2x minus 8 plus 8 equals 12 plus 8. And then negative 8 and 8 gives you 0. That gives you 2x. 12 and 8 gives you 20. Then you divide both sides by 2. And F. You should write out the check. I'd like to see that. Okay. Now, on a quick quiz, you might not have time to check everything, but if you do, check it. If you put x equals 10 in here, 2 times 10 is 20. 20 minus 8 is 12. So I checked it. I just didn't write out the check. I just did it in my head. Okay. And that one, 10 is easy to multiply by. Fairly easy to do that one in your head. The numbers are small. But you want to be in the habit of writing out the checks. And if you're not doing that, you really need to start doing it. Okay? Because we're getting to the end of what we're doing with the graphs and the pictures, and we're moving toward putting algebra on these things. And your algebra has to be up to it. The way these problem sets are set up, every problem set's just a small increment beyond something you've already done. But if you haven't mastered what you've done, it's going to be hard to make that step. Okay. So part of mastering equation solving is do the check. Okay. These are linear equations. You're not going to have any trouble with these if you practice it. There are other equations that are a little more troublesome, and we'll get to those. Some of them not for another month or two. Okay. X minus 5 times x plus 7 equals 0. Most people did okay with this. But the way I really want you to write these out is x minus 5 equals 0 or x plus 7 equals 0. The difference between or and is very important. So if you're just writing this and writing this without that logical connective, you're missing something that you're going to wish you hadn't missed a little bit later. I wouldn't necessarily penalize it on a test, on a first test over this stuff. But you're putting yourself at a disadvantage if you don't write these things out in the format I specify, at least for now. Once you have that format down, you can abbreviate it and do as necessary. So make sure you're picking up on everything I tell you. Let me stop for a minute and just note, well, I did a lecture, sent out Zoom links last week, and nobody, I don't think I remember. I had different classes. In some classes, people were all there, in some classes, nobody was there. Okay. And nobody there is okay, because, you see that we're not doing things face to face, and you're going to rely on the video. Okay. But as of yesterday, nobody had watched that video. That was class last Wednesday. You need to work through that video. Okay. So you need to get on that. Because you're a class behind if you didn't do that video. It's right there on the assignments page, and you're responsible for checking the assignments page. Okay. That's not something you can't make up, but it's something you need to do what was assigned for today, which was assignment 6 and 7. So you need to get caught up. I'll give you a little time because I know with all the disruption and everything, people can get a little off track. But there's a lot to cover in this course, and we can't get any further behind than necessary, okay? So get these things done. And everybody's doing work, but get it all done. Find time, make time. Some of you are in pretty good shape with it, and some of you are, doing okay, and some of you are obviously a couple of assignments behind, a week behind. The whole class is 2 weeks behind in 3 weeks because of the weather. Okay. But don't get behind on top of that. Um, so what else was I going to say? Oh, yeah, I was going to ask, and we'll just discuss this for a minute. Okay, I'm told that the video wasn't available from last Wednesday. And I checked and the video was marked private. It's almost certainly my fault. I must have been pretty far gone because I've never done that before. If something like that happens, if something's supposed to be there and you can't access it, because the HTML editor I use does bizarre things, and not related to what went on with YouTube, but not the HTML editor. And sometimes my link to the AI summary, for example, the thing might decide arbitrarily it's going to do a link to the file rather than to the website, and then you won't be able to see it. And I had to correct a lot of those. So do stay on top of that. And if anything isn't there, email me right away, because then I'll fix it and I'll email everybody and say, sorry, it's fixed. Okay. Okay. So anyhow, again, we're solving this problem. And also the comment I got in the AI summaries, it didn't have a lot of detail. Of course, the details in the video. However, if I ask the AI to include detail, it'll do it. Summary will be a lot longer. The reason for the summary is to remind you, not to show you all the details, but I can show. Yeah, I can get it to show more details. So I'll experiment with that. Okay. Okay. So this splits into two equations. You want to do that, because pretty soon you're going to have to do absolute value equations, and they do the same thing. And everybody screws up absolute value equations because they don't do the logic. Okay. And they're easy. So no reason to screw them up. And when they aren't easy, of course, then you really want to have the dollar. Okay. Because the only way two numbers can multiply out and give you zero is if one of them is zero, or maybe both. This equation splits like this. You get x equals 5 or x equals -7. And of course, you want to write out the steps. You want to always write out the steps to reinforce things that I find people often don't get right. Now, if you have this equation, 2x plus 4 divided by the quantity x minus 2 equals 0, then this also splits. The only way this times this can be 0 is if this is 0, if the 2x plus 4 is 0, or if the x minus 2 equals 0. Well, 2x plus 4 equals 0. Simple equation. You can solve it. And I'm not going to go through the thing because I did one similar to this. We do just similar steps. So just put ellipsis there and say that x equals 2, -2. Or x equals 2. We can check if x equals -2, 2 times -2 is 4, -4. Add that to 4, we get 0. And add 2 to -2, we get 0. So I'm going to just say, okay, I checked it. You should write out the check. Just to get in the habit of writing out the check, it only takes seconds. And it's worth the effort. Okay? Now, the one thing that you might not have seen, and every one that you might have seen to this point is always x minus something or x plus something. All of a sudden, I got a 2x plus something, right? But you know how to solve a linear equation. So all you got to do is say, well, the logic is this has to be 0 or this has to be 0. Then you just do what it says. You got that thing equal to 0, you can solve it. You got that equal to 0, you can solve it. There's a lot of stuff I can put in there that you wouldn't be able to solve, but I'm not doing that to you. Okay. Okay, now construct a toolkit scoring sheet. Okay. On the whole, class didn't do well on that. Some people did real well with it. Okay. I'm going to do it quickly because we've done it in class. Maybe it's on the video that you didn't see. Maybe that's why you didn't get it, but the instructions are also there in the assigned documents. Okay. So here's a rectangle. We divide it in the middle, as we pretty much always do. And we divide it here in the middle. Then halfway from the left edge to the middle. And then halfway from the middle, that line to the middle. Now, I sometimes see people go halfway from here to the left edge. Okay, you're almost doing it right if you do that right. But we're going toward the middle. We divide here and then we go halfway to the middle again. Then from the left edge, we go halfway to the middle. And from there, we go halfway to the middle. And we got our construction lines. Then for horizontal lines, we go halfway from the top to the bottom. That puts us in the middle, and we've already got the middle. But this is halfway from the top to the bottom, halfway from there to the bottom. Then halfway from here to the bottom. Then halfway from here to the bottom. And then once more. Then start in the upper left-hand corner. This is all written out. It's all written out explicitly, but sometimes it's easier if you see it. And I think I've done, it's hard to say what I've done in class because we've missed over half our classes in the first 3 weeks because of the weather. So things are really screwed up. So I'm not sure if I've done this other than on the video that I did on Wednesday. Anyhow, you move one line to the right and 2 lines down. One line to the right, 2 lines down. One line to the right, 2 lines down. Okay. Now, half the lines you drew, you didn't use, but they had to be there so you could skip them. Also, so you could accurately draw the lines lower on the diagram. Then 1 to the right and 2 up, 1 to the right and 2 up, 1 to the right and 2 up, and you draw your parabola. There's a toolkit scoring sheet. Then we're labeling it. If the window is bounded by x equals -4, x equals 12, and so forth, well, that means that this line here is x equals -4. This line here is x equals 12. So without doing the y lines, I'm just going to label all the x construction lines. You see, we've got 1, 2, 3, 4, 5 lines here that need to be labeled. Well, the middle one's the easiest one to find. It's halfway between -4 and 12. What's halfway between -4 and 12? Well, you could start counting -4, 12, then -3, 11, then -2, 10. You keep going until you get to the middle. easier, add these two numbers and divide by 2. Or from -4 to 12 is 16 units. You know, from -4 to 0 is 4 units, and then to 12 is 12 more. That's 16 units. Or -12 minus -4 is 16. And divide that in 2 and add it to -4. I'm going to go with add the 2 and divide by 2. And I'm going to get -4 and 12. That gives me 4. So x equals -4 plus 12 over 2, which is 4. Then halfway between 4 and 12. Well, it's easy to see if there are 8 units between 4 and 12. And if you just add 4 to 4, you're going to get 8, which is going to be this line. But if you can't do that in your head, it's fine. Add 4 and 12, you get 16. Divide by 2, you get 8. Now, what's halfway from 4 to 8? What's the number in the middle from 4 to 8? Well, it's 6, right? And you could probably do that without having to calculate anything. But if you need to calculate, that's fine. So here you got x equals 6. Halfway between -4 and 4, 0. And halfway between 0 and 4 is 2. It's not difficult. If you want a number halfway between two numbers, you can always add them and divide by 2. And sometimes these numbers are going to be big and confusing and you're going to end up with ugly decimals and all kinds of stuff, okay? And so you're not always going to be able to calculate it, but there it is. And then we have y equals 8. Y equals 32. Well, it could have worked, but okay. Well, add 8 to 32, you get 40. Half of that gives you y equals 20. 8 and 20 is 28. Divide that by 2, you get y equals 14. Add 8 to 14, you get 22. Divide by 2, you get 11. All right, and halfway between 8 and 11, just trying to figure out how to write this without getting a little scrunched up, but it's y equals 9.5. Okay. Now there's much more we could do with this. If I ask you to draw the say find x if y equals 22. How do you do that? So this might be new. I'm not sure how much of this I've done because again, I draw the line y equals 22. And I notice where the line crosses the curve. And then I draw a vertical line to this point and to this point. And I estimate the x coordinate. Okay, so I've got my graph, I've got my scale, x equals 8 here and x equals 12 here. This line appears to be a little closer to 12 than it is to 8. So we're between x equals 8 and x equals 12, but a little closer to 12. So I'm going to say maybe that's x equals 10.5. That makes sense? You just try to find the x coordinate of the point on the graph where y equals 22. So you draw the line y equals 22, identify the points, and then draw your vertical line so you can estimate x. And then we estimate x over here. It's between -4 and 0, and it's clearly somewhat closer to -4. Halfway between -4 and 0 would be -2. I'm going to say x really looks like it's about -1.5. Okay. Fairly simple process. There's a big deal to it. There's an equation that we're going to learn over the next week or so to solve. They'll tell you exactly what these are if you know what the equation of this line is. And that's going to be a little bit of a problem. Okay. For right now, I'm probably going to tell you what the equation is and ask you to verify it. And that's easy. Okay. So there is this process and a little more. Okay. And of course, I could give you an x value. You tell me what the y value is, right? So you just locate the x value, put a line there, see where it crosses the graph, and see what the y value is. This is not difficult, but it's an important step so that the next step won't be difficult. Okay, one step at a time. No step is particularly difficult. Some of them a little bit maybe, but you got to take every step in order to be able to do the next one. Now, maybe you can skip steps. Maybe you can skip 2 steps. Okay, but I wouldn't count on it. It's much easier if you don't skip steps, even if you're able to skip. Okay, one step at a time. Now, I'm not going to say too much about it because I'm going to ask you to look at it between now and Wednesday. We're weaving a bunch of different threads together here. We have sequences, we have grids, we have graphs, we have equations, okay? We have dividing by small numbers, okay? All this stuff you need to understand what's going on in pre-calculus. But there are 7 or 8 different threads. It took me way longer than I thought it would. To be better part of a weekend. Shouldn't have. But I took the problems all the way through assignment 10, maybe 11, and I separated them out into threads. So when you look at the website, you're going to see the sequence thread, you're going to see the graphs thread, you're going to see the equations thread. I recommend that you just read through those threads and see where you are, because it'll help you see what's going on with sequences. It'll help you see what's going on with equations without having to worry about sequences. Okay? Help you understand a graph without having to worry about equations. Okay? They're the same problems that you've been assigned. Just I rearranged them. And I had to do a little debugging, but that wasn't too bad. So I think those documents might be helpful. I'll give you some suggestions. In the documents, in sequence. Like, here's assignments 1 and 2. These are problems that were there for assignments 1 and 2. Okay. And everybody, I think, is doing those right. And then for assignment 4, then they appear again in assignment 6, and it tells you. And if you get down to assignment 10, well, you haven't done assignment 10 yet. So don't even look at assignment. Yeah, look at assignment 10. Look at where you're heading, but don't worry about it. They're not assigned. They're there for you to be able to see the different threads and understand how we're weaving them together. And once we do that, we get into the open math assignments, and we should be able to sail right through them if everybody has done everything they should, everything that's assigned. Okay. Now, what I'm going to do is pretty simple, and you should be well prepared to do it. And I think you are. Let's just take the equation x squared equals 25. Okay? Hold up fingers and tell me a number that would satisfy that equation. Is there a number that you could square to get 25? What times itself equals 25? One answer. Well, okay, let's see. What's 2 times 2? Hold up fingers. What's 3 times 3? 9. Okay. Now 4 times 4, 16. 5 times 5, 25. Okay. You need to know the multiplication tables well enough to know at least squares of numbers up to 100. Okay. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. If you've done all the arithmetic in your life on a calculator, it's going to be hard to think about what this is telling you. Okay. So you really need to remedy that a little bit. And, you know, okay. Should be obvious that if you square 5, you get 25. So x equals 5 is a solution. Because 5 times 5 equals 25. X equals -5 is also a solution because -5 times -5, you multiply a negative by a negative, you get a positive, right? And 5 times 5 is 25. So this equation splits into 2. X can be 5 or X can be -5. Solution set is a set of numbers that include -5 and 5. We use these braces to indicate sets. Okay. Let's see right out. Solution to x squared equals 9. As I expected, everybody wrote it out correctly. You might not have written out the solution set, but it's a good habit to do that. Okay, now let's see if you can solve this one. x squared minus 5 equals, oh, let's say, walk around and look at what you're doing this time, but write it out, think about it, but not for too long. Okay, now I'm going to tell you. First thing you want to do here, just like with a linear equation, we're trying to solve for x, so we isolate x. We put a plus 5 here equals plus 5 here. So that's where we add 5 to both sides. Preferably then write out x squared minus 5 plus 5 equals 4 plus 5. X squared minus 5 plus 5 is just x squared. 4 plus 5 is 9. And now it turns out that this is just a disguised form of this equation. Okay? Add 5 to both sides, we get x squared equals 9. We get the two solutions. How about this one? Two x minus 7 quantity squared equals 16. What can you do with that? Earlier, I'd let you ponder that for a few minutes. Some of you might already see what you do. I'm going to explain it. I'm saying that something squared equals 16, right? Well, what number squared equals 16? Show me with your fingers. 4, right? Or negative 4. This tells us, just like over here, except it's a little more complicated, 2x minus 7 equals 4, or 7 equals negative 4. That makes sense? We're saying that something squared is 16. What's squared? The 2x minus 7. So whatever's being squared has to be 4 or negative 4. That means 2x minus 7 has to be 4 or negative 4. So then we solve this and we get x equals 11 halves, or x equals 3 halves. Then we plug it back in and check. X is 3 halves, 2x is 3, 3 minus 7 is negative 4, and you square negative 4, you get 16. 11 halves times 2 is 11. 11 minus 7 is 4. If you square 4, you get 16. So it's a matter of understanding that when something squared equals a number, then that something that's being squared is going to be the square root of that number, or the negative square root of that number. Okay? Something that you're going to need to do in set 8. We'll see what's actually assigned for when, but let's see what else we can say. Okay, moving on a different thread. Here's our scoring function, right? Or our squaring shape. If we make a table of this shape, what I mean is we make a list of x and y values. What's the x value at this point? It's negative 4, right? And what's the y value at this point? It's 32. So we make a table. We say when x is -4, y is 32. It's easy, isn't it? Hope. Okay. Now we go to the next point that we made in the construction. We went over to the next construction line and then down 2 construction lines, and we have this point. Well, this point is where x equals 0 and y equals 14. So when x equals 0, y is 14. Now, right 1 and down 2, we get to this point, and we can see, because we've labeled the construction lines, that this is at x equals -2, and the y value is 9.5. We have this line here, which incidentally coincides with the red dot. The red dot's going to be an important point. The square function, the red dot, is on the lower edge, right in the middle. Okay? But that point has x equal to 4, because that's right between -4 and 12. It's x equals 4, and y equals 8. Then this point is on x equals 6 and y equals 9.5. And then the next one is on x equals 12 and y equals 32. Now, if you look at the y values, you see they go 32, 14, 9.5, 8, 9.5. Shoot, I left one out. Didn't do this point. Here where x equals 8 and y equals 14. And then we have x equals 12, y equals 32. Sorry, I left that point out. Again, now what we're saying, we got 32, 14, 9.5, 8. If we go here, we got 32, 14, 9.5, 8. That is, these numbers are symmetric about this. If I go up one space, I get 9.5. If I go down one space, I get 9.5. If I go up 2 spaces, I get 14. If I go down 2 spaces from the x equals 4, y equals 8, I get the same thing. Okay? And you can see how the graph is nice and symmetric around the center line, right? If I sketch a vertical line halfway, I see that if this is a mirror, then when this thing looks in the mirror, it sees this. You can have a mirror image. And that's an important property of the squaring shape. Now, one thing you'll be asked in homework is to make a table with different boundary lines. -2 to 2, 0 to 4. Simple 4x4 rectangle. Okay. And that's really kind of easy to do, but we want to see how you do it, how well you do on it. Okay. Um, I can't do that without giving it away. I want you to work through it. Uh, Function notation. I'm recording or not? Yep, I am. Okay. Let's say we got y equals f of x equals 3x plus 6. Now, some of you might not have seen the f of x notation. This is just a way of naming the function. Function name is f. Functions like a machine, okay? Kind of like your calculator. If you put 3 into your calculator and hit the squaring button, it's going to give you 9, right? So that squaring button is actually a function that's electronically assembled in a calculator, okay? Your input would be 3. You put 3 into the calculator and you execute the function by hitting the square button, right? Now, if the function, you don't have your calculator doesn't have a 3x plus 6 button, it could, but you don't want to write a button for every possible linear function. You'd have an infinite number of buttons. You never find them. Okay, so you have this formula. So if you want to know what this function puts out, if x equals, okay, y is the output. So if I want to find the output for x equals 2, we replace x 2. So here's the definition of your function. Please write out that definition. And then just below that, write out what you get if all your x's are replaced by 2. Very simple. You're just writing it out with x's and then write it out in using 2 instead of x. Write that down on your paper. I want to see you do that. Okay, what I said was write this out again and then write it out once more, replacing all the x's by 2. So we got y equals f of x equals 3x plus 6. Replace all the x's by 2. You get y equals f of 2 equals 3 times 2 plus 6. Okay? Literally write this out and then write it out again. And the only thing you change is you replace all the x's by 2. Okay? That makes sense? Do that. Don't do it intuitively. Do it until it's intuitive what you're doing. Okay? Some of you are probably familiar with function notation, which is very good. So that's the process. Then you can evaluate it. You can say, okay, so now equals 6 plus 6 equals 12. One person even started making a table. Said when x is 2, y is 12. So you could put that as a point on the graph, couldn't you? We're not going to do that right now. We're just going to concentrate on the function notation because function notation is a big hang up for people. Three-quarters of the class will do it wrong for a month. Never understand it. Okay? This is how you understand it. It's just substitution, it's just replacing x by whatever's in that set of parentheses. Okay? So tell me, what's f of a plus b? Well, right now, the way I want you to answer that is, okay, you write down y equals f of x equals 3x plus 6, and replace x by a plus b. Right, so if x equals a plus b, then y equals f of a plus b equals 3 times a plus b plus 6. All right? Literal substitution. Don't do any arithmetic or any algebra with it until you've done the literal substitution. Okay? Very important. So you'll have problems where you're asked to do that. Do it in this form for your own good. If you do that in several problems and just do it mindlessly without worrying about what's going to happen next, then there are a lot of mistakes that you're going to avoid and a lot of confusion you're going to avoid. Okay. Um, Here's a sequence, pretty obvious sequence. So jot down that sequence and then tell me what's A of 2 and what's A of 5. Now, actually, the way it is, A sub 2, A sub 5 equals. Okay, where this is A sub 1, A sub 2, A sub 3, A sub 4, A sub 5, A sub 6, etc. You understand what I'm saying? So what's A sub 2? Write it out. A sub 2 equals A sub 5 equals. Just want to see if you're locked in this notation. Sure, everybody. Okay, so everybody has correctly identified that A sub two, well, that would be 16. It's the second member of the sequence. A sub five, you don't necessarily have to write A1, A2, A3, A4, A5. You just count A1, A2, A3, A4. A5 is 28. It's fine to write this out. That's important. But there it is. Okay. Now, to change the value between A2 and A5. Put it in the hole. Okay. What's changed between A2 and A5? Well, it's 22, right? Because from 16 to 28 is 22 units, right? So it's actually A5 minus A2, 28 minus 16, and that's 22, right? I said it's 22. I've been trying to calculate this with 22, finding out that I'm not getting the right thing. It's 12, not 22. Okay. So just bonehead error on my part. Change is 12 between three members of the sequence. Is 12 over 3, which is 4 per member, right? Does that make sense? You've moved over three members and the change is 12, so the average rate of change is 4 for every member. Okay, well, what's the change from A1 to A6? Well, you can see that that A6 is 32, A1 is 12. So it's 32 minus 12 equals 20. Change per member. is 20 over 5, because from number 1 to number 6, that's 5 members, right? And you can see on the board here, that's 1, 2, 3, 4, 5 members, gives you a change of 20. And it's still 4. Okay, well, this is really pretty simple, but it's preliminary to something that's really, really, really important. Okay, it's preliminary to the whole idea of rate of change, which is the most fundamental concept in calculus. Okay, so we want to build it up gradually. It's a very simple question. Everybody understand it? Understand what's going on here? Be able to answer questions of this nature? Okay, now, I think you were assigned up through number 7 for today. Okay. Many of you had work up through number 6, which is pretty good considering. But let's see if you get number 7, everything done through number 7, if at all possible by Thursday. If you run into something, you have trouble, do the easy ones first. Okay. So if you have trouble with something, we can see what the trouble is. If you don't have any trouble, then well, you won't have to spend time on that. But if you do have trouble, we can see where it is. Okay. Most of the problems are pretty straightforward. If you know what we're doing here, you probably ought to be sure you look at that video that was misposted. And it's only a couple of days till Thursday, so I'll understand if you don't get every bit of it done. But that just means you're going to have a little more to do over the weekend. Of course, you have more time over the weekend. Okay. And we'll see where we are on Thursday. So y'all did pretty well here.